So this is study guide 4. This is going over, what chapter was that we just did? Chapter 9, right? Yeah, chapter 9 in Zumdahl, which is about stoichiometry. So here's the first question. How many moles of water are made from the complete reaction of 1.4 moles of hydrogen gas? Well, what we need to think about here is, what does this chemical equation mean? So the chemical equation that we're given says 2H2 plus O2 goes to 2H2O. So we can interpret that in terms of numbers of molecules, or dozens of molecules, or moles of molecules. Mole is the chemist's dozen. Mole is number of things, not mass. So this is 2 moles, and this would be 1 mole, and this would be 2 moles. And remember, MOL is the abbreviation for mole, not the abbreviation for molecule. So we have 1.4 moles of hydrogen gas. So what we're going to do to help us, figure out what we're doing here, because deciphering the word problem is half the battle. Hydrogen gas, under H2, we're going to write 1.4 moles. Because we're told that's how much we have. The question is, how many moles of water? So under water, we're going to do question mark moles. Now we know where we're starting and where we're ending up. We're starting with moles of hydrogen, and we're going to moles of water. So that orange, what I'm writing in orange is what I would like to see on your paper. And then I'll write in blue just kind of sort of background-y stuff. So our path here, which you can write down if you want to, but it's not necessary, is the path is 1.4 moles of H2, and we're going to moles of H2O. So if you're struggling, you should write that down. But showing your work. Okay, so that's our path. It's a one-step path, and so we just have one conversion factor. 1.4 moles of H2, and we have one fraction. Equals. The units go in first, moles of H2O on the top, and moles of H2 on the bottom. The H2O on the top because that's where we're going, that's part of our path. The H2 on the bottom because we want those to cancel out. So we get our units in place, then we go looking for numbers. Mole ratios come from the balanced chemical equation. In front of H2O is the number 2. So in front of moles of H2O, we put the number 2. In front of H2 in the equation is a 2. And so in front of moles H2 in our equation down here, we put a 2. And so for every 1.4 moles of hydrogen, we'll multiply by 2, divide by 2, we're going to end up with 1.4 moles of H2O. Put a box around it so I can see what your answer is. Okay, so now you should work on number 2 and number 3. And ask me questions if you need some help. Question 4, how many grams of chlorine gas are needed to make 117 grams of sodium chloride? So we do have to have some understanding of nomenclature here to at least be able to recognize what these compounds are. We're given a balanced chemical equation, and we're going to use that to organize the numbers, the information from this question, this sentence. Make sure I got the right color here. Okay, so how many grams of chlorine gas? Well, let's find chlorine gas in this equation. It's Cl2, question mark, grams. How many grams? That's what we're looking for. Needed to make 117 grams of sodium chloride. Sodium chloride is the NaCl, and 117 grams. So this question is saying we want to end up with 117 grams of sodium chloride. How much chlorine do we need to start with in order to make that much sodium chloride? So back to the pancakes, which I actually made pancakes for my kids last night. They're all gone. Double batch of pancakes. 4 little kids and me. Well, I guess my husband had a couple. All the pancakes gone. They just inhaled them. But if you're wanting to make a certain number of pancakes, we didn't do pancake. We did sandwiches. Sorry, it's the other class that did pancakes. If you're wanting to make a certain number of sandwiches, you often have to figure out, well, how much bread do I need? Or how much meat, or how much cheese? You can't just go buy some stuff and hope it works out. Sometimes it works out, but if this is a big deal, you better make sure you have enough, right? So that's what this sort of question is. We want to end up with this much product. How much do we have to start with? So we identify what we've got here. And so we start with grams and we end with grams. And so this is our mantra, right? Grams to moles to grams.
I yelled at my roommate last month.
Did you? That's good.
He just kind of looked at me.
Like, you're losing it, dude, right?
You yelled the grams, moles, grams.
Grams to moles to grams. It's important. Gotta remember that. Okay. Sleep deprived.
It was in my head and he walked in.
Yeah, when you say the first thing that's in your head, grams to moles to grams. Not the answer to everything, but it helps with a lot of things,
I
actually.
just knew he wouldn't ask me to explain it to him.
But if he had asked you to explain it, you would have been ready, right?
Yeah.
And we given him
Even
more.
if I wasn't, I could have told him.
Yeah.
Something.
That you didn't understand.
Yeah.
That was right.
Yeah.
Yeah.
It's always nice to
I
just
love doing that.
blow people away, right? It's really fun.
With stuff that's not true.
The stuff is not. It's
Just
even
because
better if it is true.
Just because it sounds so amazing.
Yeah, that's easy to do. So this is what we're starting with. This is the number that we're given, grams of sodium chloride. And our path, grams to moles to grams, has 3 arrows. We need 3 conversion factors, 3 relationships here. The path tells us what to put on the top. Grams of sodium chloride to moles of sodium chloride. And from moles of sodium chloride to the moles of the thing that we're looking for, which is Cl2. It's important to write those formulas. Like I'm having trouble fitting them in. You may be having the same problem on your paper, but it's important. Because otherwise, grams of what? Grams of chlorine, grams of sodium chloride. You got to have the unit and the chemical formula. So we put those in. This is just dimensional analysis, the units telling us what to do. So down here, we're going to put moles Cl2 so that those cancel out. Down here, moles of sodium chloride, so that the units cancel out. All about the units. And then we need numbers. The middle one is easy. The middle one is a mole ratio. It comes from the balanced chemical equation, which we have right in front of us. In front of Cl2, there's no number. We understand that to be a 1. So I'll write a 1 in there for those of you that really want to see a number there. In front of sodium chloride is the number 2. What does that mean? That means for every 1 mole of chlorine that we use, we will get 2 moles of sodium chloride. The first conversion factor and the last one are molar masses. And so we have to calculate those. Sodium chloride has 1 sodium, 22.99, and 1 chlorine, 35.45. And I think those add up to 58.44, which is a little scary that I remember that. So that's grams of sodium chloride, which is equal, let's is really messy. Which is equal to 1 mole of sodium chloride. That's what a molar mass means. It's the mass of 1 mole. Okay, yes, there are 2 moles of sodium chloride in the equation, but here we need the mass of just one of them, because that 2 coefficient gets used in the middle term. Don't go putting it in other places. So down here, I'm going to squeeze this in, 58.44. And then we need the molar mass of Cl2, which is 2 times 35.45, which I think is 70.90. It's grams of Cl2 equals 1 mole of Cl2. So that last term then is 70. I'll try that a little better. It's always nice for your writing to be legible to other people. So that's the hard part. We've gotten all that down. Now don't screw it up by miscommunicating with your calculator. Okay, some of you have some calculator issues that honestly scare me a little bit. But we'll say that that's not your fault. We'll blame it on the public education system. So if you're setting up your equations correctly and getting the wrong answer, please talk to me, and I'll have a word with your calculator, okay, and we'll figure it out. Because it's a shame to do all the chemistry right and then get the wrong answer and lose points just because your calculator is misbehaving. Although we know it's actually you telling your calculator to misbehave, but it's okay. So I came up with 70.97. Okay. I'm just thinking that's awfully close to the 70.9. Is that okay? Well, that's what it is. It is what it is. We're going to round that to 3 significant figures because the first one is 3 significant figures. So some of you have issues with rounding as well. 9727, and it just goes on. 3 significant figures. So if you're having trouble rounding things, write it down and then count from the first non-zero digit. We've got 1, 2, 3. This is the last digit we're keeping. We're rounding to the nearest tenths place. Okay? I know for a fact that you do this in like 2nd grade, 3rd grade. Round to the nearest ones, round to the nearest hundreds, round to the nearest thousands. Okay? Because my kids are doing that. So we're rounding to the nearest tenths place. The next digit is 5 or greater. We're going to round up. So that 9 rounds up to a 10. And we're like, what do we do with that? Well, that rounds the 0 up to a 1. And so we end up with 71.0 grams of chlorine. I'm putting that 0 in there because we were rounding to the tenths place. We're not just going to drop it. Your calculator drops zeros all the time, but your calculator is stupid. Okay? It doesn't understand these things. Any questions? So now you can do number 5, and then we'll work on number 6 together. So question number 6, talking about waffles. I'm sorry, it's lunchtime and you're probably hungry. What's the theoretical yield of waffles if you have 5 cups of flour, 9 eggs, and 3 tablespoons of oil? And what is the limiting ingredient? And here we're given a very simple recipe for waffles. Don't try making waffles with this recipe. It won't work. It needs like baking powder or something in there too. Well, let's take we have our equation there, and let's take these numbers and put them in, so just to kind of organize our information. So we have 5 cups of flour. So under flour, I'm going to write 5C for 5 cups. We have 9 eggs. And we have 3 tablespoons of oil. And the question is, what's the theoretical yield of waffles? And that is a theoretical yield, especially with waffles, because they're easy to screw up, aren't they? Get them in the waffle iron and they break coming out or something, and whoop, there goes one waffle. So theoretical yield. Everything works perfectly. How many can we make? We're going to take each ingredient and find out how many waffles could we make if we used up all of that ingredient. So the first one we're going to do 5 cups of flour. And we're going to use that recipe to see how many waffles can we make for each amount of flour. Well, it says that we get 4 waffles for 2 cups of flour. Seems like those must be awfully big waffles. Cups of flour is the unit, and we want the units to cancel. So we've got 5 times 4 is 20 divided by 2. So if we used up all the flour, we could make 10 waffles. Now, this being things that we can actually see and feel and eat, it probably makes a little more sense, which is why we're doing it. So that's if we used up all the flour. What if we use up all the eggs? Well, we've got 3 eggs, and we're going to get, well, let's just be consistent. Put the units in first. Waffles for how many eggs? Well, the recipe says 4 waffles for every 3 eggs. Okay, what did I do wrong there? This isn't a 3, it's a 9. Call that a brain fart. Excuse me. We're starting, we have 9 eggs. We want to find out how many waffles can we make if we use up all the eggs. So eggs cancel out, and we end up with 12, right? If we used up all the eggs, we could make 12 waffles. Can we make 12 waffles, though? No, because we ran out of flour at 10 waffles. And then we're going to do the other one, the oil. So I'll try to do it correctly this time. 3 tablespoons of oil. I didn't leave myself much room. Squeeze it in there. Waffles and oil. So 4 waffles for every 1 tablespoon of oil. If we use up all the oil, we could make 3 times 4, or 12 waffles. So those units cancel. So right now, we have 3 answers. We're not done because we have to choose one answer. What's the theoretical yield? Well, in theory, we could make 10 waffles. So put a box around that. That's you're choosing this as your answer. And then, this question number 6 actually has 2 questions in it. It's 2 parts. A lot of students just answer the first question and they ignore the rest. If there's explain or why, they just skip that part. I don't want to do that. It's not a good idea. Answer all the parts of the question. So what's the limiting ingredient? What's limiting? It's the flour.
So we just circle the flour.
You can just circle it and then write LR over here, and that makes perfect sense to me. Or you could write flour is the limiting ingredient, but somehow you have to indicate that flour is the limiting ingredient. Any questions? Okay, so then you get to do number 7 and figure out the tricycle factory. Question number 8, study guide 4. What is the limiting reactant for the following reaction, given that we have 3.4 moles of calcium nitrate and 2.4 moles of lithium phosphate? What is the theoretical yield of lithium nitrate? So you need to add the red stuff in there because I left it out of the worksheet. Oops. Okay, so let's organize our information here. 3.4 moles of calcium nitrate. So let's write that under calcium nitrate in the equation. And 2.4 moles of lithium phosphate. 2.4 moles of that. And the question, what's the theoretical yield of lithium nitrate? So over here, question mark. There's another little piece of information missing, isn't there? What unit? What unit?
Moles.
Yeah, let's do moles, right? Because it's easier, right? That's why I picked lithium nitrate, because that's easier to calculate the molar mass of than calcium phosphate. But actually, we don't even necessarily have to calculate that because it doesn't ask us for grams. I need to edit this. So we'll just say that it's moles, because it's Friday and we're feeling lazy. So the question is using words limiting reactant. So that's a clue that this is a limiting reactant problem. The other clue is that we're given 2 amounts. We're given 2 amounts. The other ones we were given just 1 before the waffle one. And we were calculating the product. Here we're given 2. So this is like the waffle one. We need to take each of the ingredients that we're given and find out how much product can we make. So our path was grams to moles to moles to grams, right? Let's write that out in case you've forgotten that. Grams to moles to grams.
But why do we have to do that?
Well, we don't. But sometimes students are grams to moles to grams. I gotta get grams in there somewhere.
But it's moles. So.
But it's just moles, exactly. So what I've seen people do is they get all, I don't know, they lose their mind and they take moles and convert them to grams and then try to convert them to grams and to moles. And they turn this inside out and that doesn't work.
Because you gave me a map, I didn't want. That would be me.
Okay, but see, this is Dora getting airlifted in. She didn't have to take the first part of the journey.
I missed the flight.
And there's a helicopter waiting for her to pick her up, so she doesn't actually have to climb the snowy mountain. So it's not cheating. What happens is on the exam, they're multiple choice, and just because it's so much easier, I just make all the questions of equal value. Well, if I give you a question like this, that's starting with grams of 2 reactants and asking for grams of a product, that's a big old hairy problem for Chem 10 students. Okay, that's a big problem. But we need to have limiting reactant problems on the test. Well, a mole-to-mole question is a lot easier, except that the students can't recognize that it's easier, and so they make it really hard and wrong and screw it all up. So I'm warning you. I'm doing this example for you, okay? Keep your thinking cap on, okay? Keep your brain on and don't just go into rote doing something. We're given moles. Now, I left something out. We should be asked for moles. Okay, but what if we were asked for grams? Well, if we were asked for grams, then we would have to include that last step. And that would be okay. We can do that. So this is the path, but you could get dropped in at one of the intermediate steps, and you could decide, well, this is where I'm going. We're just going here. We don't need to go any farther. Okay? Dora's got a helicopter waiting to lift her out again. Okay, so she just needs to do that middle step. So don't make these harder than they need to be. So we're just doing moles to moles in this problem. Okay, so that makes it a lot easier because it's just one step for each equation. So let's start with the first one first. So 3.4 moles of calcium nitrate. And yes, it's tedious to write those formulas. Get over it. What are we trying to find? Well, we're trying to find moles of lithium nitrate. And then we want our units to work out. So we put moles of calcium nitrate in the bottom. So they cancel out. And that's it for that one. What's the ratio? Well, there's a 6 in front of lithium nitrate, and there's a 3 in front of calcium nitrate. So we take 3.4 times 6 divided by 3, and I believe that's going to be 6.8. So 6.8 moles of lithium nitrate. When I'm doing problems in class, you should have your calculator out, and you should type the numbers in also. Because sometimes I screw up and do it wrong. I'd like to say it's on purpose, but actually it's not. I make mistakes. That's one ingredient. Now we're going to do the other. 2.4 moles of the lithium phosphate times, and again, this is one conversion factor. Moles of lithium nitrate on top and moles of lithium phosphate on the bottom. So the units work out. In front of lithium nitrate in the equation is a 6, and in front of lithium phosphate is a 2. What was that, 7.2? I'm doing that in my head, which is very dangerous.
Because I think because it didn't have the moles, I just assumed it was grams that we had to go to.
Well, and that's, unfortunately, I didn't write this question well. You could do this question and solve for the theoretical yield in grams. You're going to have the same answer for the limiting reactant. Did anybody else get 7.2 moles? Okay. Because I did that on my brain calculator, and that one doesn't work so good. So we have 2 answers. Which one is the answer? You can't have 2 answers. The smallest one.
When we did it with the conversion from the 3.4 moles into grams, and we did the 2.4 moles into grams, the second one came out small.
That's because you did it inside out, and you can't do it inside out. You can't go moles to grams to grams to moles. We'll look at that. Okay, we'll look at it. We'll keep it off YouTube. So we're doing this calculation, and we find 2 amounts of product, whether they're moles or grams. The smaller one is the theoretical yield. You can't make any more than that, because at that point, this guy over here has been used up. This is the limiting reactant, the one that forms the smaller amount of product. So the limiting reactant is calcium nitrate. The amount of product, theoretical yield in moles, is 6.8. Any questions? So question number 9 is similar, except that it gives you masses in grams and asks you for a mass in grams. And then question 10 gives you theoretical yield and gives you an actual yield and asks you to calculate percent yield.